Dear all, my name is Lotta Rydhmer and I'm a professor in animal breeding at the Swedish University of Agricultural Sciences. Welcome to this lecture on sustainable production of milk and meat and sustainability assessments. The first of my two lectures within the EU project called GenTORE. Let me first introduce myself. My area of interest is breeding for a more sustainable food production. I have worked at the university for more than 30 years, but when I was young, I used to work with dairy cows on different family farms. That's long ago, and both the conditions for farmers and animals have changed since then. The change of the animals is largely due to selection. It's a genetic change. The changed conditions for farmers are partly due to political decisions and competition on a global market, and partly due to climate change. All these changes are, of course, connected with each other. If you're a dairy or a beef farmer, or an advisor in milk or meat production, I assume you are concerned about climate change and other environmental impacts. You may also feel a pressure of an ongoing discussion about sustainable animal production. The public discussion on ruminants is often focused on climate change and methane emissions, right? With this lecture, I want to give a broad overview on strengths and weaknesses of milk and meat production. And the second aim of this lecture is to introduce life cycle assessment, a tool to assess the sustainability of a production system. This lecture has two learning outcomes. A broad view on animal production's environmental impact, and knowledge about life cycle assessment. Sustainable production is often described as a production built on three pillars: environmental, or sometimes called ecological, sustainability, social sustainability, and economic sustainability. In my lectures, I handle economy as part of the social sustainability. For example, a reasonable income for you as a farmer is part of the social sustainability. When talking about sustainable agriculture, most people think of environmental sustainability. The climate impact of 1 kilo beef or the nitrogen leakage associated with 1 kilo milk is important indeed. But I believe social sustainability is equally important. That is also shown by UN's Sustainable Development Goals. Most of them include both environmental and social activities and goals. There are several ways of assessing the sustainability of the production of goods and services. One common approach is life cycle assessment, in which the impact caused by the production is related to the amount of products produced. A fundamental principle in life cycle assessment is to follow the impact of the product all the way, from production to consumption, and from consumption to handling of waste and recycling. Think of the screen where you see me now. How has your screen be produced? And how will this screen impact the environment and people during its lifetime? How much electricity was used to produce your screen? Was this electricity produced on coal or on wind power? Was the screen transported to you on a van run with fossil fuels? And what happens when your screen is broken? Will the battery, if it has a battery, and other components be recycled? Is that done with toxic solutions? We must also think of the steps before your screen or your laptop was built at the factory. These steps may include heavy metals from mines. What about the impact on rivers in the country where cobalt or lithium mines are located? And what about the working conditions in these mines? In a life cycle assessment, all inputs are traced from the production side back to their origin. If the product is food, the boundaries of the system are less evident. When the food is eaten, it's gone, and we see it more as a chain rather than a cycle. But handling of food waste and sludge from sewage treatment plants can be included in a life cycle assessment. Now, imagine beef as the product that we study here. Inputs to the farm could be electricity, fuel, and fertilizers. And imported soybean meal could also be an input. And then we have to include the cultivation of this soy in Brazil or China or wherever it comes from. Maybe you haven't heard of soy from China, but actually soybean was domesticated in China many thousand years ago, and today China produces soy for organic production in Europe. The environmental footprint of soy production in China and Brazil differs, and working conditions also differ between these countries. So when evaluating the sustainability of beef, we should consider not only the production on the farm, but also the inputs, such as feed, fuel, and fertilizers. It matters how these inputs were produced, and it also matters how the manure is handled on the farm. Therefore, the environmental impact of two farms can differ a lot, even if the farmers are neighbors and produce the same product. For example, raise dairy calves for slaughter. Consequently, the result of scientific studies on environmental impacts can differ depending on the inputs and the outputs of the system. We want to assess sustainability to be able to describe the impacts of the production, to provide a base for well-informed decisions and wise choices. The assessment should help us doing a fair comparison. For the industry that wants to improve their production over time, for the consumers wanting to achieve a sustainable diet, for the politicians wanting to stimulate sustainable production and consumption. Now, wait a second. Are we talking about production or consumption? Let me give an example. In Sweden, one of the national environmental goals is to reduce eutrophication, to reduce nutrient leakage into the sea. Agriculture is responsible for a large part of this leakage, so a quick fix would be to close all farms. But also Swedes like me, we have to eat. Yes, but we can always import food. Less farms in Sweden, higher fulfillment of the eutrophication goal. But then we have, of course, just moved the problem to another country. Thus, we should analyze the impact of both national food production and production of imported food, because we are responsible for the whole consumption of food of our population in our country, right? Likewise, we are responsible for the inputs imported from other countries as the soy or the pesticides or the fertilizers. The life cycle assessment, it's a tool for fair comparisons of products, and it's a tool for identifying so-called hotspots. Hotspots are stages in the life cycle that cause the largest impacts. And it's important to identify such hotspots so that we can invest wisely in reducing negative impacts of the production. The assessment is done for a certain product or service. It's called a functional unit. In our case, the functional unit can be 1 kilo of beef on the plate of a consumer, or 1 kilo of milk, maybe fat and protein corrected milk. If we want to answer the question, what is the most sustainable protein source for humans, chickpeas or milk? Then it's better to use the functional unit 1 kilo edible protein. We can present the results of the assessment as, for example, gram of toxic substances used per kilo edible protein. Now remember, we have also social issues. I think you can imagine how to calculate the amount of toxic substances like pesticides for feed production per ton milk or beef. And also number of work accidents per ton milk or beef. But what about worries and nightmares of farmers? Amount of worries per ton beef? That is difficult to measure in a quantitative way. We often need a qualitative assessment of social issues, and I will come back to that in the next lecture. Milk and meat production systems are complex, maybe more complex than the production of the screen or the laptop that we talked about a minute ago. We can't include everything in the life cycle assessment. For practical reasons, we have to set boundaries and we have to make simplifications. For example, we can choose to exclude vitamins and minerals in the feed because their impact is so small compared to the rest of the inputs. We can choose, for example, to exclude the production of the tractor. Without tractors, there is neither milk nor beef, and the fossil fuel input for the tractor on your farm should be included when analyzing your production. But we may ignore what's going on at the factory where the tractor is produced. Let's agree that the factory is outside the boundary of our assessment. 2 points about boundaries for a life cycle assessment. First, responsibility. I think it's fair to leave working conditions at the tractor factory to the tractor industry. Let them do their own sustainability assessment. Second point, when you compare results from different life cycle assessments, always start by checking the system boundary. Many life cycle assessments of agriculture production ends at the farm gate. If there is one life cycle assessment of outdoor beef production based on pasture and another life cycle assessment of indoor beef production based on concentrate and silage, it's a relevant question to ask which production system is most sustainable. If the first study ends at the farm gate and the second study ends on the plate of the consumer, the results are not fully comparable. Both studies can be good science, but their boundaries are different. However, what happens after the animal has left the farm has a quite small influence on the total results of a life cycle assessment on beef. So let's think of another example where the system boundaries really matter. Assume one study takes the land use change related to feed production into account, and the other study does not include the land use change. Example of land use change is when feed production is associated with deforestation. Forest is cut down in order to increase feed production. It is complicated to calculate the land use change in, for example, Brazil, but it matters for the results of the LCA of your beef production. If one study takes land use change into account and another study doesn't, then the results are not comparable. But of course, we can still learn from both studies because both studies can reveal hotspots that needs to be improved. Next question. What aspects should we include in the life cycle assessment? What are the issues within milk and meat production? I've already said that both environmental and social issues matter, but let's start with the environmental issues. Here is a list for a life cycle assessment. Climate change, acidification, eutrophication, energy demand, ecotoxicity, land use. These are often included in a life cycle assessment. And an ambitious life cycle assessment also includes biodiversity.